All right, let's get going on section 9.2, which is measuring area and volume. Um, Area is a two-dimensional plane, flat surface. Measures the square units placed inside. It is a multiplication process. Often using formulas. Volume is a 3D shape that encloses a containment, like a shoebox. Poo, a gallon of milk. Yes. These three-dimensional shapes are in cubic units. All right. So we're going to start here our lesson on a shape. And we're going to count them. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 20 square units. It could be written as 20 units squared. But the square, the little 2 has to be on the language of what we measured. Well, we know that this is some kind of a rectangle. An area for a rectangle is length times width. So we have 4 times 1, 2, 3, 4, 5 rows in measurement. So we have 20 units squared. Well, this is just an example of how area works. It's the inside measurement. In square units. Excuse me. All right. So, what if we have a shape that's like this? Well, we know this is a triangle. So in a triangle, we're going to count the full shapes. 1, 2, 3, 4, 5, 6. 2 halves make 7, 8. So we have 8 square units. And the measurements being feet, inches, meters, or whatever. But we know that the formula for area of a triangle is area of a triangle equals 1/2 base times the height. Well, this is the height and this is the base. So we have 1, 2, 3, 4. 4 for the height. And on the base, I have 1, 2, 3, 4. So if I multiply that, half of 4 is 2 times 4. Area is 8 square units. Now that's the importance of understanding the inner measurement of items. Even though we say they're square units, we're talking about a half here, a half here, a half here, and a half here. But in mathematics, we just want to know the inside measurements. We always have the pieces to make it stand. So let's talk of something called ratios, understanding the ratio concept. We'll be using this more in chapter 10 than we are in chapter 9. But we introduce it here because of the reference to unit fractions. Now, these unit ratios give us a concept of relationship of the numerator and the denominator of reference items that we're going to do much more in chapter 10. So rewrite the ratio so that the units in the numerator and denominator are the same. So we're going to convert something. Use values in terms of small measurement units. Then, that should be then, write the ratio in fractional notation, expressing it in simplest forms. So here we have 108 inches to 11 feet. So 11 feet is a different measurement. So we're going to convert to inches. All right, so I'm going to put my 11 feet and I'm going to multiply by 1 foot equals 12 inches. This way, my feet cancel and I end up with an equivalent value for that. So let me use my calculator, clear it, and I'm going to do 11 times 12. And I'm going to get the value of 132. All right, so now I have 108 inches to 132 inches. All right, so now it says write the ratio in the smaller measurement unit. 108 inches to feet inches is 108 inches to 132 inches. So now these guys match the inches. Okay, the fraction in simplest form. Well, we have 108 inches to 132 inches. In this case, the inches go away because they're the same unit of measurement in the numerator and denominator. And now we have to simplify. Now we're going to use the calculator because I made you buy it, and you might as well know how to use it, right? Absolutely. So, to convert ratio to lowest terms. All right. Rather than beating you on the head over this, we're going to just write the steps. First, numerator divided by denominator on home screen. Okay, that's what we do. Then, the second step, we're going to, so for this guy, we're going to do 108 divided by 132 and enter for decimal value. Okay, the next step. We're going to immediately go to the math key, and then on next window, choose number 1 frac and enter. And the third step is to read the fraction in lowest terms. All right, so let's do this concept here. I'm going to get my calculator, move it over here, and we can see what we did. All right, let me push it up just a little bit. 108, right, divided by 132, enter. I get that ugly thing. Then I'm going to hit the math key, which is the third row, first key. There's the frac, enter. So it says answer converted to a fraction and enter. And I get 9/11. And that's the lowest. Well, what we would have done, or could have done, I should say, is divided by 4. Let's just divide it by 4. Well, 4 would make it 2, and 28 is 27. This would make it 3, 12, and 12, 33. Well, then we would divide by 3. And we would have 9/11. Did we get the same thing? Yes. But you paid a big amount for these calculators, and it can be just about anything if you're patient enough to learn it. All right. So this is for your calculator notes. So make sure you have a little page for that. So here we go. We're going to continue on now with our dimensional analysis. Here we go. So on this next example, we have 16 centimeters squared area in metric to area in American or English. All right, so I'm going to start with my 16 centimeters squared. That's my area given. I need to get rid of centimeters squared and get inches squared. So I'll look, And I notice that the first one is the one I need to use for my identity. So it says 6.5 centimeters squared is equivalent to 1 inch squared. Now, once I do that, the inches squared, I'm sorry, not inches, but the centimeters squared uh, cancel, and I end up with my desired change in measurement. So this gives me 16 divided by 6.5 inches squared. So I'm going to do a decimal because it says round to the nearest hundred as needed. So let me get my calculator. Let me clear it. And I'm going to enter the 16 divided by the 6.5. When I do that, I get this ugly number, 2.4615 dot dot dot, keeps on going forever, and I want to the hundreds, so I have 2.46 inches squared, and that's my answer. All right, well, let's look at this next one. In this next one, I'm going to start with the 32 meter squared metric, and I want yards squared. So I'm looking here and I see yard squares with meters squared. So that's the identity I'm going to use. So I need to get rid of meter squared. So meter squared is in the bottom, and I have a decimal 8 to equal 1 yard squared. When I cancel the numerator and denominator of the two fractions, I end up with a new change of value. So I'm going to end up with 32 over 8 tenths yards squared. Now I need my calculator. So I'm going to get my calculator. And I'm going to enter the 32 divided by decimal 8. And I'm going to get 40. And that's version. These are all using all the tables. You don't have to write the tables down. They come out with your problem as I've shown you. On this one, I'm starting with 11 inches squared, and I'm converting to centimeters. Well, we've done a couple of those, and that's more or less the more likely to utilize. So I'm going to use the very first one, inches to centimeters, and I need inches in the denominator. So I have 1 inch squared is equivalent to 6.5 centimeters squared. So in this case, my inch squareds cancel, and I end up with centimeters squared. Again, the area connection. So that's going to give me 11 times the 6.5 centimeters squared. I'm going to enter that in my calculator. And I have 71.5 centimeters squared. All right. Well, now we're going to volume. And as I described before about volume, I mentioned that it involves containment of something. Shoes, perfume, cookies, cereal, all of those have volume in them. Okay, volume refers to the amount of space occupied by a three-dimensional figure. In order to measure this space, we begin by selecting cubic unit, the cubic unit. Volumes end in cubic unit. 1 cubic foot is 12 cubed, because 12 inches in a foot times raised to the third power is 1,728 cubic inches. 1 cubic yard, 27 cubic feet squared, because there are 3 feet in a yard. And cubing it would give us that value. And I got this from the textbook because it shows you the dimensional analysis in picture form, which makes it really nice in concept. So let's begin this. Definitely not difficult, but we're trying very well to understand the dynamics of what we have. So in volume, we're usually talking about a three-dimensional shape. And here we have some kind of a box. And it's asking us to find the volume in cubic units. All right. So I can do it several ways. I can count the top and double it, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 cubes twice. So I have 32 cubes. Well, we know then that the volume of a rectangular solid is length times width times height. The height is right here. This is the height. It's 2. The width is 1, 2, 3, 4. And the length is 1, 2, 3, 4. So what happens here is I have 16 times 2. Oh, look at there, 32. Because this is the 2 rows and this is the cubes per row. And this is in cubic units, or units raised to the third power. Either way, it's always after that number. So now we're looking at contingencies for capacity. Capacity is what is put into. What fills the volume that we just had. The containment is it holds the capacity. And here we know these things because most of you are young enough to have done the gallon man. 2 pints equal a quart, 4 quarts equal a gallon. 1 gallon is 128 fluid ounces. Not to be confused with weight, which is plain ounces. Fluid ounces means that we have a containment or some form of a liquid type of item that fits into that item. Volume in cubic units. Volume in cubic units. And capacity. That means what kind of liquid will fit in a cubic volume. All right, 1 cubic yard is about 200 gallons. 1 cubic foot is about 7 and 48 hundredths gallons. 321 cubic inches, about 1 gallon. So, let's see, I think I had a problem there. No, I did. Now we're looking at using that information to work some problems. So here we go. And we'll see how we can do this. Okay, use the table along with dimensional analysis to convert the given unit to the unit indicated. So we're talking about 10,000 feet cubed, and this is volume, and we want the capacity. All right. So feet, cubic feet to gallons. And of course, we see what we need. 1 cubic foot is worth 7 and 48 hundredths gallons. So I'm going to multiply by the feet on the bottom and the gallons on the top. All right, now I can cancel feet cubed. I know you saw the 3 on that. And I'm going to end up with 10,000, times the 7.48, and the item is in gallons. So we change to a capacity. And we'll use our calculator for that. And we get 74,800 gallons will fit in 10,000 cubic feet. Pretty cool. All right, now we got this again, a table with everything we need. And here's our request. Inches cubed, which is volume, to gallons capacity. All right, cubic inches to capacity. That's the last entry we have in our item. That's my puppy, Sadie. So we're going to set up the problem. 2722 inches cubed. Sadie, stop. Sadie. And the gallons we want to cancel the inches cubed. So we have 231 inches cubed gives us about 1 gallon. So we got the inches cubed canceling, and we end up with capacity. And that gives me the value of 2722 over 231 gallons. Now we're going to stick that in our calculator. And I get this horrible number. And we're going to round to 2 places. And we're going to have 11 and 78 hundredths gallons is our solution, or our conversion, I should say. All right, I'm going to stop right there.